Good morning, everybody. Nice to see everybody again. We're taking the liberty of moving this lecture out under the tree in the quadrangle. I hope you don't mind. I don't see anybody moving. Okay. Well, good morning and welcome to number 3 of 4 MLA lectures this spring. Spring is definitely in the air, as you can see. And this year, as you know, the topic of the lecture series is the modern university. I'm Steve Ehrlich, Interim Dean of University College. Hardly a day passes without some public debate about higher education being on the front pages. Conceal and carry at UTexas, Austin. Freedom of expression at Mount St. Mary's, Maryland, over a controversial retention plan. Washington University students lobbying for cutting ties with prison investments. And by the way, all important conversations we should be having with our students, colleagues, and other stakeholders. After all, informed, constructive, civil debate and discourse is one essential role of a modern, responsible university. Maybe some of our presidential contenders should go back to college for a refresher course. But there are other things, goals and challenges that define great universities which can be overlooked if we confine our views to the public face of the institution as portrayed on websites and on social media. In the first 2 lectures of this series, Bob Wildenberg and Jen Smith, from different but complementary perspectives, spoke to the roots of higher learning and the liberal arts, and how the history is played out today as colleges and universities walk those tightropes, using Jen Smith's image, tightropes between theory and practice, public and private, intrinsic knowledge and marketable skills, in deciding what constitutes innovative teaching and learning. Jen also reminded us all that ultimately we're here because we love to create, teach, and disseminate knowledge. And we do that increasingly under close scrutiny and valid concerns about the opportunities and the limitations associated with higher learning. Which brings us to today's speaker and topic. Barbara Schaal is Dean of the Faculty of Arts and Sciences and the Mary-Dell Chilton Distinguished Professor of Biology at Washington University. Barbara was born in Berlin and grew up in Chicago. She earned her undergraduate degree from the University of Illinois and PhD from Yale. In her spare time, Barbara studies the evolutionary genetics of plants at a university like ours with a long and distinguished history in the plant sciences. She is a plant evolutionary biologist who uses DNA sequences to understand evolutionary processes, such as gene flow, geographical differentiation, and the domestication of crop species. Her current research focuses on the evolutionary genomics of rice. In addition to her academic leadership as Dean of the Faculty, Barbara is a recognized leader in her field and more broadly the contribution of science to the sustainability of our planet. I think you'll hear more about this in a few minutes. A short list of her achievements and affiliations clearly illustrates Barbara's leadership. Chair of the Division on Earth and Life Studies at the National Research Council. Member of President Obama's Council of Advisors for Science and Technology. Former President of the Botany Society, Botanical Society of America, and the Society for the Study of Evolution. Member of the U.S. National Academy of Sciences and the American Academy of Arts and Sciences. Appointed U.S. Science Envoy by former Secretary of State Hillary Clinton. And this month, she assumed the presidency of the American Association for the Advancement of Science, the world's largest scientific society and the publisher of the well-known journal Science. The goals of the AAAS are to promote cooperation among scientists, defend scientific freedom, encourage scientific responsibility, and support scientific education and outreach. What this adds up to, indisputably, is that Barbara Schaal is an exemplary teacher-scholar, a role that is centerpiece at any great university like this one, and one that informs much of her thinking as Dean of the Faculty about teaching, research, scholarship, service, all important pillars of excellence in a modern university. So please join me in welcoming Barbara Schaal to talk about arts and sciences, the heart of the university.
Thank you. That was quite the introduction. It's just me up here. It's weird. So I'm going to talk about something that I'm really, really interested in, and that is what is the future of a university, what parts of a university are very important, and obviously my thesis is going to be that arts and sciences is the center of a great university. It's just wonderful to see all of you here. I see a lot of friends, and that's really terrific. And also, it really is very nice to see you, even when it's so absolutely gorgeous outside. I think all of us kind of had a moment where we went, ooh, do we really want to sit in a dark room listening to someone? So what I want to do first is talk a little bit about what I see as some of the challenges that universities have. And these are things I'm sure that you've heard already and are probably very familiar with. So universities, their relevance are being challenged. What is the relevance of studying 18th century Chinese poetry to the challenges that we face today in our society? Those are valid questions. I think all of you who've studied 18th century Chinese poetry, of course, know the answer to that. There's comments on the human condition. There are questions about the cost of universities. A university like Washington University, a really elite private school, is extraordinarily expensive, and that puts burdens on families. And then the question about access to all economic groups becomes very important as well. Parents rightly say, what about job creation? After I've spent, I don't know, $300,000 on a Washington University education, is she going to get a job? That's a reasonable thing to ask, particularly when you think about the job market. And then another aspect that I think challenges university right now is sort of the general public anti-intellectualism that we see. There's a lot of dialogue going on. I think it was reflected most when a while ago there was someone running for a public office, and she was introduced to a teacher and just rolled her eyes. That kind of says everything. So there are challenges out there. So I think it's very important for universities to be able to justify and to talk about their relevance. So what is the mission of the university? All of you know this, but I want to go over some of the aspects of it. Of course, education. This is a picture of Harvard Yard in the 1950s. And at that time and much earlier, a university education was for the elite. It was for wealthy families. This was where they put their children and sort of shepherd them from childhood, adolescence into adulthood. There was, of course, the obligatory tour of Europe for a year, and by the time you finished that, you were ready to go into whatever the family business was. Now, of course, universities are very, very different. We are accessible, much more accessible. A lot of this happened with the GI Bill, where the former Army and Navy and military people came back to the United States, and there was this mass opportunity for education. And there was a change in the idea of what a university education was. It was the idea that it provides it should be within the reach of all. Of course, that isn't the case. We still are not available for everyone. And then also that it provided the necessary education to go on to whatever one's life work was. So you had the opportunity to go on. And there were many new universities, and of course the wonderful community college system. So a real change in what universities do. Education is absolutely central, of course. Another mission of the university, and a very strong one, and one that I deal with a lot as Dean of the Faculty, is that of providing scholarship. This is really central to what we do as a university. We disseminate knowledge, we educate, but we also create knowledge. So this is scholarship and discovery. Initially, as this picture shows, it was something that men of means did. And this is a scholar in his library reading through some of the books. It was a very isolated pursuit for many people. Today at Washington University, we expect all of our faculty to be engaged in discovery, engaged in scholarship. And we also expect that they will bring their students into the acquisition of knowledge. That's a very important part of what we do. And our scholarship is across all the traditional areas, from the humanities and social sciences to the natural sciences. And also we have a lot of interdisciplinary programs, and I'll say more about that later. Another aspect of universities, and this is one that isn't often talked about, but I do talk about it with some of my colleagues in the humanities, and that is the importance of universities as keepers of history and culture. What you see on the top left is the Elgin marbles. On the top right, that is from some Bronze Age petroglyphs from Sweden. At the bottom, 2,000-year-old pottery figures from the Han Dynasty. And then also some corn from Native Americans. This was a very important part of their culture as well. So understanding our culture, understanding who we are as people, understanding the lessons of history and how they apply to what we do now, understanding societies, and this knowledge is extraordinarily important. It's not just an academic, if you will, focus and sort of a self-serving thing. It's very, very important for our societies. And so that's another aspect of what we do as universities, and it's a very important one. And that particularly is associated with the humanities and the social sciences. So what do we do in arts and sciences? It's at the center of the university. These are where we do the basic studies of the sciences, the basic understanding of the social sciences, how societies work together, and also the basic understanding of the humanities. And from these basic studies, this basic knowledge stems the professional schools. So business relies on economics in good part, and some other disciplines. Law and social work are based on a lot of the fundamental studies of sociology. And in fact, when sociology was brought back to Washington University, there was tremendous enthusiasm from a lot of the other deans, because this was the basic. We had a hole in the university. We needed the basic studies of how societies work. Medicine comes from a deep understanding of biology, the cell and molecular processes. And the physical sciences, of course, contribute enormously to engineering. So we really are at the center of all of the activities that go on, the core of the universities. So one of the things we want to think about is, what do universities, given these challenges, given these missions, what does a university look like 5 years from now, 10 years from now, 20 years from now? I'm going to go over 3 areas that are central for arts and sciences, what I see as the future. And this is a very personal view. Obviously, other deans and other faculty members will have different views. So 3 areas. But there's others that I'm not going to speak about. One is the importance of continuing education. You know, here you are on a beautiful Saturday morning, and you're listening to somebody blather on about the future of a university. Continuing education is really important. We have an important role in entrepreneurship, taking discoveries and moving them forward into business and into opportunities. We have an important component that deals with the community interaction, and that's going to be more important as we go into the future. And we also have a huge clinical medicine operation, very important for Washington University. So I won't be talking about these things, but they are very central to what a university is. I'm going to be looking more at arts and sciences. So what does a university look like in the future? One of the things that I feel very, very strongly about is that we must have a dialogue in arts and sciences and at the university on contemporary societal issues. Traditionally, scholarship, and I am as guilty of this as anybody, it tends to be very deep and inward looking. We develop these fascinations. I'm absolutely fascinated by the genomics of rice domestication. This is not a great public sort of concern, but it is something that we do deeply, and it's the same with studying the Chinese poetry or understanding the structure of labor unions. So it tends to be very inward focused, very technical, and somewhat obscure, at least to the person out on the street. But I think that given the societal issues that we have right now, that inward focus, while we must have that, is not enough. I maintain that we also need to have a role in addressing our societal issues, the challenges that we have. And there's a lot that the Academy does, a lot that we do with our basic research that in fact speaks to these societal issues. And so, here are some of them that I've listed. The major ones: inequality, racism, education, our judicial system, gun violence, healthcare. These are all topics that we have a lot to say on. One of the things that we were watching my husband and I, some show this morning, and they had one of these commercials where there's some medicine that they're hawking, and so visually you see pictures of happy people, running through the woods or something like that, and then most of the verbal was talking about all the potential side effects: coronary artery disease, heart attack, you're going to lose your nose, your toenails will fall off. It just goes on and on and on. And as a public, what do you do with that? And so there's this disconnect between the message that you're seeing and the message that you're hearing verbally, and what do you do as a healthcare consumer? We have things to say about this. We need to keep our strong disciplinary expertise, but the Academy has much to offer, and I think a university in the future, we're going to be part of that dialogue. We have to be part of that dialogue if we want to thrive, if we want to really be relevant. And of course, if you look at the university previously, what it did, we were relevant. We provided education and knowledge, and that was appreciated by society. Society is changing. We need to change a bit as well. We also need to keep the very scholarly mission, and I'll have more to say about that. So let's do a deeper dive into arts and sciences. If we look at the social sciences and the humanities, these are some of the things that we do. I think, as all of you know, there is a Washington University program on gun violence. It's viewed as an issue of public health, but it has many, many manifestations of that. If you think about psychology, for example, we think that psychology is extraordinarily important. We learn, we understand how we learn, we understand how our brain functions, how we form opinions, and we can look at the effects of social media in a psychological way. So lots and lots of things that are really relevant. Justice, guns, judicial system, forensics. We have a prison program for education through University College. These are all the kinds of activities that we should be doing while still doing an outstanding job of education and an outstanding job of our own scholarship. So these are important aspects in the natural sciences. There are other things that challenge us. These are areas that I think science needs to speak out about, such things as climate change. This is lovely weather, but believe me, we're at way one end of a deviation from normal. This is beautiful but very frightening weather. Vaccines, the controversies around vaccines. You have all of these discordant voices. Physicians, 99% of the physicians say there's no issues, but yet you have this public kind of interaction where we have deniers and fear of vaccines. Genetically modified foods, lots of concern about that. Scientists have something to say, universities have something to say. Stem cell therapy, this is kind of a sad thing, where there are companies that will hawk stem cell therapies that are completely unproven. It's not allowed to have these therapies in the United States, so you'll have clinics in different countries, and there's no scientific basis for them. So it's very, very frightening. Teaching of evolution, something that I've been involved with a lot. And then the other thing is the importance of evidence-based thinking. So you can see that at Washington University, we do lots of different things that really relate to this. And so the challenge is for us to really speak out in these areas. So what other things are important for the university of the future? Well, obviously, a thriving university is going to have inter- and transdisciplinary work. there's been a real change in the academy in the kind of research that many of us do. What traditionally the scholarly areas tend to be very siloed with almost no overlap between them. And what we're seeing is a complete breakdown of those silos. So this is a picture from our Institute of Materials Science and Engineering. It is a secondary ion mass spectrometer, SIMS. And it's actually a very cool machine for understanding the composition of materials. There's one of two in the United States, and it's used by earth and planetary science, by chemistry, by physics, by engineering, and also we have industry coming to use this. It's a very different kind of activity for a university. Not only interdisciplinary, transdisciplinary, but also industry comes to use it. And you can see this is different than someone sitting in an office working on something theoretically. So the fields just blend into each other. And this is really important work because you think about what a university does, particularly a university like Washington University. We're a small research place. And on the Danforth campus, over that way we have engineering, and there we have the humanities, and then we have business and law and the natural sciences. We're all on the same campus. Many of us eat lunch at Holmes Lounge. And so there's this opportunity to have collaborations very easily. And you see that happening here. The other thing is we're in the Midwest and we tend to be a little more relaxed and friendly, so it's pretty easy to develop these conversations. This is really where the university is going to go in the future. And it's very exciting because there's some really interesting things that can come from that. This picture at the top, this organic synthesis, this is from a chemistry laboratory, and basically chemistry and medicine are coming together. Our chemistry department wants to go much more into medicinal chemistry. And then there's even more collaboration on this. There's some tremendously exciting work on nanomedicines. So nanoparticles are little teeny tiny particles with different kinds of shapes. They come together and they have characteristics and properties that are different than if they weren't very fine, if they weren't nanomaterials. And so what you can do is to take a particular drug from the medical school, maybe worked on with the chemistry department, take a nanomaterial done by physics and by engineering, and put the drug on the surface of the nanomaterial. Sometimes it's like a sphere. Sometimes the drug is on the inside of this nanomaterial. And it'll have these unique properties. It'll do something in some cases like go through the blood-brain barrier. Sometimes it's really hard to get medicines into the brain because of that barrier. And these materials can go through that. So very exciting work. And medicine, the Department of Medicine couldn't do it alone. Department of Chemistry couldn't do it alone. Engineering couldn't do it alone. And physics couldn't do it alone. So there's lots of exciting work that's going on. That's going to be a characteristic of universities in the future. In the social sciences, this is really cool. This is a picture of the connectome of the brain, how all of the neurons and everything connect, how we are wired together. It's extraordinarily complicated, large data sets, and this is basically the brain just simply showing you some of the wiring. So we're mapping the brain. This is done in our Department of Psychology and Brain Sciences, Psychological and Brain Sciences. They just changed their name. They used to be psychology. And it's in collaboration with folks at the medical school. So basic, fundamental understanding about how we're wired. And then for undergraduates, this really gives these wonderful opportunities for our undergraduates. We have a program in philosophy, neuroscience, and psychology. And what this does is it goes all the way from understanding something like this, how we're wired together, to the psychological consequences of this, how it deals with behavior, and then all the way through philosophical issues. And so one of the things that philosophy deals with is how we perceive the environment, how we perceive the outside. And so that gets right into neurobiology. And our students can go all the way across all of this. It's really very exciting, a very well subscribed to undergraduate major. Another area is the environmental sciences. And This is where we have a new program that we've just ramped up in environmental studies. It used to be focused in biology and in political science for the policy aspects of the environment, biology for the ecological, and then also in earth and planetary science for the physical environment. The way that we're conceiving environmental studies now is vastly different. Sitting at the table are folks from the Sam Fox School because of landscape architecture and their interest in the urban environment, in modifying the urban microclimate. We have folks from engineering that are dealing with atmosphere and pollution. We have people from law dealing with environmental justice. And so you just see how the whole university is changing, because what we're doing is we're looking at these societal issues and understanding that it's not just one area. It's not just the environment, the physical environment. It's not just the biological environment. It's people, their interaction with that environment. And as soon as we bring people in, then we deal with law and business and visual design and all sorts of other different things. So a very different kind of university. This is what we see in the future. It's pretty exciting, too. There's a terrific program in the humanities. We have a Center for Humanities. It's headed by Jean Allman. And this is something that's been very, very exciting. Just as the sciences do and the social sciences do, the humanities very often will tend to kind of focus inward. And what the Humanities Center does is to bring our distinguished faculty and postdocs and visitors all together at one location and to have these much broader conversations. Funded by the Mellon Foundation is a very large grant to look at the divided city. It's looking at urban issues related to the inner city issues versus the suburban issues. We're actually looking in a different project all the way out to the ex-urban environment, and looking at it from, again, a transdisciplinary way. This is in a collaboration with the Sam Fox School of Design, a collaboration with the Humanities Center, and many of the departments. So this is the kind of thing that I think a university should be doing. Again, we need to maintain our disciplinary expertise. We need to be scholars, but we also need to think about what the social context that we're in. And I feel that we have a real obligation as part of the university to reach outward. And finally, another thing that I just wanted to bring up, again, another component, one of many, of thriving universities of the future, and that is how to educate students, how people learn. And you heard from Jen Smith, who's absolutely fantastic at understanding this, and she's been a terrific leader. But we know that if we want to be relevant in the future, we need to apply the lessons that we learned from psychology about how people learn. We need to apply that in the classroom. We need to do inquiry-based classrooms, flipped classrooms, hybrid classes, research, internships, and service learning. So change the way we educate. What we know now is what I'm doing right now, standing up and lecturing at you, that's not the best way that people learn. And if you really want to engage students and get them not only to learn long enough to do a test and do well on a test, but to learn and really incorporate things, then you need to change the way we do things. The other thing that I think is very important, and we don't do a real good job of this, is to focus on transferable skills. These are pictures from our Tyson Research Center. And again, this is a place, it's about 30 miles from here, about 30 minutes from here, and it's an old military base. That makes it sound dreadful, but it's really not. It's a beautiful forest now, and we use it for an environmental experiments, environmental study. Lots and lots of our students go there. And when they go there, they learn not only how aspects of the environment, book learning on the environment, but they learn to understand how the environment works by actually doing research. One of the things we must do as an academy is to make a better case for the benefit that we give our students. One of the things that I love doing, and with completely unanticipated pleasure, is I really enjoy talking to our alumni. Now, obviously, anybody that comes and talks to me is going to be pretty happy with Washington University. It's pretty unusual to have someone come up and say, I really hated it. So I'm dealing, obviously, with a very nice sample. But you'll ask somebody, someone who, one of our National Council members, works at Skechers. And she majored in history. And so I said, how did you go from history to being a vice president at Skechers. And what good, if you will, what good was your history major? And she said, well, I majored I did a lot with China. And so I understand their culture and their history. And at her business, she has to go to China and deal with factories and things like that. And she says, I'm very effective because I had that understanding of people, of culture. And then she said, I learned to write. One of the things we do at Washington University is our students write. They learn to write. They learn to read a text critically. They read a text critically. These are the skills that come from the humanities, which is why the humanities, if we talk about arts and sciences being the center of Washington University, in my mind, the humanities are the center of arts and sciences. So in those humanity classes, you learn to read a text critically. You learn how to frame an argument. You learn how to write. In our social sciences and natural sciences, you learn how to understand data, what evidence means. And we understand it from the humanities, culture, and diversity. I asked a young alumnus, this was amazing, who was very high up in a financial firm and doing really, really well. And I love to ask people, what was your favorite WashU class? What was the most influential? And I was figuring he was going to say, macroeconomics of small businesses or something like that. And he said, the most influential course I took was Introduction to Women's Studies, because it was the first time I ever saw the world through someone else's eyes. That's what we do. How critical is something like that? How important? So this transferable skills, the importance of undergraduate education, it's discipline-specific knowledge, but it's also these really flexible skills. The last thing I'm going to say about that, and this I've talked to Mahendra Gupta, our dean of the Olin Business School. One of the things he's worrying about is how do you train students for jobs that aren't there right now? So we know that the world is changing so fast, the technical world, the business world, things are moving so quickly that it's really hard when you're sitting in a classroom to think about when these students graduate, what are the jobs going to be that they're going to take? They're going to be different than the ones that are here now, even over a period of 4 years. So how do you train for that? Well, I think you have basic skills, the ones that I just talked about. I think the best example of this, and the one that I can actually make some traction on, is when you think about the founding of Google. I mean, that has completely changed the way we do things. The folks that founded Google did not take a class entitled How to Found Google. Nobody knew what Google was. So there has to be these basic skills, these skills of communication, understanding, logic, dealing with data sets and evidence that we have to pass on to our students. And those are the marketable skills because we don't know what those jobs are going to be in the future. The other thing that I wanted to talk about is graduate education. And graduate education is different than undergraduate education. At least in arts and sciences it is, because again, we're dealing with the basic subjects of the understanding of knowledge, the understanding of topics. So graduate education is very closely related to discovery, to scholarship. And if someone in biology, for example, or in East Asian languages and cultures works towards a PhD, this is scholarship, this is discovery. They are going into a classroom, a library, a laboratory, and developing new knowledge. They're being trained to become a scholar. So it's very different than taking a whole series of classes in a number of different areas. So quite a difference between the PhD education in particular and an undergraduate. So this is an area that's extraordinarily important. In Washington University, we want to enhance our graduate education. That's something that Bill Tate, the Dean of the Graduate School, is working very hard on. We view it as central to really enhancing the scholarship of our faculty, the scholarship of our departments. And there are some new ways of training graduate students. So there's some exciting things that are going on here as well. One of the most exciting things is in the humanities, for example, there's the digital humanities, using large data sets. This is really very different than 20 years ago. So humanists, because now all the texts are scanned, they have the opportunity, for example, to look at a particular word and see how the meaning of that word changes through decades, through centuries. and how that might be correlated to what societal things are doing. So lots and lots of access to text in a way that never was available before. So we need to train our graduate students in new ways, for example, in the digital humanities. And this goes with many different kinds of areas. We have a program, the Institute for Material Science and Engineering, which is joint between arts and sciences and engineering, and we have a whole number of PhD students that are doing these interdisciplinary kinds of things. Again, very different kind of graduate education. So one of the things that we feel is really important is maintaining vibrant graduate programs for education. The other thing that we want to do is to train for different kinds of jobs. Traditionally, the PhD was to train scholars, so my graduate students, many of them wanted to just kind of do what I did, be a professor at a university and do research and teaching. We now know that this is an unsustainable situation. So I've had 35 PhD students. Obviously, there's not that many jobs out there. So we have to rethink about what the PhD is. And I remember very long ago, a very distinguished professor here said, if you look at people who have degrees in law, most of them don't practice law. They do other things. But going through law training gives you some very critical skills that can be applied in other areas. And that's what we're beginning to see in graduate education, where our students are demanding, and many of us are now delighted to give them a different kind of education. Some of my more recent PhD students want to work and are working in Washington on policy issues. So they come with a deep understanding of biology, environmental studies, and they're now using that for policy decisions. So there's other kinds of conversations. Again, the academy is changing, and we need to be really flexible and to move with those changes. So the last aspect of a university that I want to talk about is the importance of maintaining strong disciplinary scholarship. And this has two components, and I'm going to go a little bit into detail on the first one, and the second one I'm going to talk a lot more about. So this graph on the right, this is a typical kind of graph on any kind of measure of how a university is doing. This one happens to be endowment per student. We could talk about NIH funds. We could talk about many sorts of different things. Universities rank and compare themselves in many, many different ways. Washington University is the red bar. You'll hear very often that we're worried about our ranking, but rankings really don't mean anything. But in fact, they do mean something, because a university that is highly ranked is reflected in outstanding education and outstanding scholarship. And if you want to maintain and do a good job of scholarship and of education, you need to have good students and you need to have good faculty. So the ranking, in fact, does affect what we do, and universities are very interested in maintaining their ranking. It turns out that ranking is based on scholarship in a very strong part. It's not just education. We do really well in undergraduate education. We have some extraordinarily distinguished disciplinary programs, but we also have opportunities to move others of those up. And one of the byproducts of that will be to have a higher ranking so we can get better faculty and better students and more endowment and just do the whole thing better. So that's one aspect of it, of maintaining the strong disciplinary scholarship, because our reputation, in fact, feeds into how well we do. The other aspect is one that I'd like to go into quite a bit more. This picture on the right is a picture of the front of a book called Rising Above the Gathering Storm. And this has a very interesting history. This is about 10 years old. What happened was the National Academy of Sciences was approached by senators on either side of the aisle, and they asked the Academy if you could come up with 10 things that would help, that they could do in Congress to maintain the economic viability of the United States, to maintain our technological work and economic viability. What could we do to make sure that we as a country flourished? And of course, economic viability, jobs for people, that then affects general well-being. It affects, if people have good jobs, they have good health, they have social stability. So all of these things relate into how well a nation does. So what are the 10 things? And what this pointed out was that, and this was headed by Norm Augustine, who was the retired CEO of Lockheed Martin. There were a number of people on it, a couple Nobel laureates, university presidents, so really a blue ribbon committee. What do you do? How do we work to maintain this? And what they came up with was that we needed to have strong basic research, strong scholarship across a large number of different fields. And the reason is that having these basic discoveries that come from the laboratories at universities, and that's where most of this is done now. There's been a shift, and I'll talk about that later, but most of it is done in our universities. This kind of basic research is critical for the viability of the nation. And then what they worried about and made a lot of recommendations for is to maintain this pipeline of basic research. So I want to talk a little bit about basic research. It's critical, they concluded, for the economy of the United States, for the health of our populations, for the structure of the United States. And so the question was, how do we keep this basic research as the food stock, if you will, of the future developments in science and technology that will result in our economy doing well? And if you look historically, it turns out science and technology has been very, very critical. We were, until the 1950s, an agricultural nation. But that agriculture was based on new varieties of plants that were bred, was based on new technologies for plowing and harvesting, things that people don't think about anymore. And then we've had other revolutions such as well, I'll talk about these in just a moment. So let me just tell you what we're talking about, explain this a little bit better. So what I want to do is to talk about basic research. This is fundamental research which is done for only one reason, and that's because people are interested in knowing more about something. There is no goal here. The only goal is to understand. There is no sense that this is going to have application. It's just we want to know more about something. So at the top here, there are some of our students looking at a geological site. So understanding geology, how rocks are formed, the age of the Earth. On the left is just astronomy, understanding the nature of the universe. We don't expect a gain when we go through all these equations. You just want to know. Here's one on the left bottom. That's one of the nanoparticles. They're so cool. And that comes from just basic chemistry and physics. People were just interested in this stuff. And that has led then to the nanomedicine, which is really exciting. Understanding the properties of light. I'll have more to say about that. And then at the bottom there, that's photosynthesis, how plants are so fabulous, because what they do is they take a photon of light, they take a bit of energy from light, they shoot it through all of this, boom, and you end up with carbohydrate energy in a chemical form. So they take light energy and convert it to chemical energy. And folks are really interested in this, not only in understanding it, but you can imagine if we're dealing with energy crisis, can't we fix the photosynthesis a bit more? This is basic research. Again, it's curiosity-driven, goal-driven, fundamental research. It's contrasted with applied research. And this is where you actually do have a goal. So breeding new varieties of carrots, we're not understanding much more about a carrot, but we are making a better carrot. But all of these discoveries that we see here, transportation, the aviation industry, cars, the medicine, solar energy, iPhones, all of the technology, all of that stuff is based on basic discovery. And this is a picture on the top of Vannevar Bush, and I called him out because after World War II, he was the first head of the National Science Foundation, and basically what he said is in order for our country to be viable and to maintain itself, we need to have basic research. So he made the case with Congress and with the public that we needed to have a really flourishing research enterprise. And one of the real challenges of having this basic research enterprise is this problem. is that you can say, okay, I'm going to dump $1 billion into understanding, to doing solar energy. But the problem is you don't know what basic research is going to actually lead to some kind of a development. It's a real challenge because certainly members of Congress will often say, well, why are we funding this basic research where people are just, kind of contemplating their navel? We need to fund research that's going to give us a product. The problem is you don't know what that research is going to be. You just don't know what research is going to yield something that's really important. This is, of course, Einstein, and I'm going to have a lot more to say about him. So Einstein did relativity, space-time continuum. He did the quantum nature of the universe, of physics, and he did a lot of, and all of this was theoretical, just brilliant. But when you think about what he did, does this really have any kind of application to anything? Because this was theoretical, it was equations, and it was mind-blowing in 1916, 1906. But it turns out, in fact, to be extremely important. So I'm going to ask a question. How many of you used a GPS to get here? Anybody? Okay. You would be 10 kilometers away from here if it wasn't for Albert Einstein. So, and let me explain what this is. We live in a Newtonian world. We're on the surface of the earth. You drop something and gravity doesn't change, and we don't go through time-space warps and things like that. But GPSs are really interesting. So what the GPS does is global positioning satellites is they basically have, they've got satellites all around the earth. And what they do is they have very, very accurate clocks, like to 50 nanoseconds, and that's really accurate. So all of the satellites are on the same clock, all the GPS receivers are on the same clock. And what they do is they shoot some light, and we know how fast light goes, and it goes from the satellite, boom, down to your GPS. And then one over here goes, boom, down to your GPS, and another one over here, boom, and pretty soon you can triangulate. It's just Euclidean geometry. Except when we're dealing with satellites and us on Earth, we're no longer in a Newtonian world. We're in a world of relativity. And it is really, really interesting. So the first thing that happens is you've got us on Earth here, gesturing. So think about, you've seen those windmills, like when you go on I-70 and you see that one by the construction company. If you look at the axis is turning around like this very, very slowly. If you look at the end of the blade, it's going really, really fast. I always look at those blades and think, boy, if you were sitting on the end of that, that would be terrifying. So what it means is that your car GPS is going, is going at one speed, and these satellites are roaring at a different speed. Well, what that does is you're now in a relativistic world. And it means that the time changes. When you go really fast, time is slower. So the GPS has to correct for that time difference because of the different speeds. Then the other thing that happens is that the GPS is sitting on the Earth, and then the satellite is up here, and it has 4 times less gravity. And so what that does is it warps the space-time continuum, and you have to correct for that. So this is so significant that within an hour you're going to have problems with location. GPS will get you down to 3 meters. It's really accurate, and we know that the military can do much better than that, probably. I'm sure they can. So you have to correct for that, and it's an order of magnitude difference. We want nanosecond precision, and there's microsecond problems with the relativity. So the GPS computers have to correct for that. Otherwise, within a day, you're 10 kilometers off of where you want to be. So who would ever think, right? So you can't predict. That was the point. It's a couple of, I love these examples. So another one is penicillin. So you don't see this too much anymore because we put stuff in our bread, mainly salt, so that we don't get bread mold. But in the old days, you used to get a lot of bread mold. And the mold is through a group of species called Penicillin. And a fellow Fleming was studying this, and he had a Petri dish, and that's what this is up here. It's a Petri dish. It's about this big, and you put some agar, it's like jelly in there, like just some Jell-O, that has all kinds of goodies for bacteria to grow on. And then you take a little needle and you dunk it in a culture bacteria, and you just whoosh, like this. And then after a few days, you can see the little squiggles of the bacteria growing. But if you happen to be unclean in your laboratory techniques and get a spore of penicillin right there, the mold grows because it's a yummy agar. And what you can see is around the upper edge of the mold, which is the white dot at the bottom, there's clear. There's no longer any bacteria there. And that's because the penicillin mold produces antibiotics. And so this was, again, somebody studying stuff, and all of a sudden, boom, we have the first antibiotics. And of course, that made a huge difference in terms of public health. And now we have many others. And people are still discovering antibiotics from some of these molds. Again, non-directed research, just trying to understand the world a little better, and you get these important things. I want to go back to Einstein. So we want to talk about lasers. And the laser, I like this just simply because it says the laser, a solution looking for a problem. So this starts again with Einstein. And what he was interested in, looking at the quantum theory, he predicted theoretically that if you put a single amount of energy at the correct amount into a substance, an atom, that it would be so energized that that same energy wave would come out except amplified. And that's what a laser does. What it does is it takes some light of a particular color, it shot into a substance like a ruby crystal or something, and it is amplified in that by various means, and then what comes out of that is pure light of a single frequency. And people were working on this. It started out that this must have been that the government, some of the military people were watching Flash Gordon or something, that this was first done experimentally. The idea was maybe we could create a death ray for World War II or something. And it turned out that that wasn't the case. They worked on trying to do this amplification and understand the nature of light by looking at shorter and shorter microwaves, and eventually they came up with an understanding with radar, which is really important. But then they wanted to make, again, this kind of death ray, and it turns out, of course, that it wasn't a death ray. It just was this pure light, and folks said, well, what good is that? And of course, I think the rest is history. Laser surgery. We have laser-guided weapons, a laser printer, fiber optic communications. We do that by laser now. Barcode scanner, CD player, printers, hologram authentication. Just everything is related to the laser. So this is a great example. Again, starting out with an equation by Einstein, and then a bunch of guys initially really only wanting to understand the nature of matter, and then ultimately to something that has just really revolutionized the way that we live. So again, you cannot predict, and that's kind of the exciting thing, but also the real conundrum. Another example, this is one of my favorites. This is a hot spring in Yellowstone Park, and the different colors are due to different kinds of bacteria. So one of the things that people are very actively investigating right now is bacteria that live in what we would consider extraordinarily hostile environments for life. This is boiling. That's a hostile environment for life. When you have really high temperatures, the proteins that you have, the things that shepherd all of your cell, your life processes, they denature and they don't function anymore, and things die. But yet, here in this hot spring, you've got bacteria that are doing all of these processes, and they're able to withstand that. So there were some scientists at Indiana University that were beginning to look at this. How is that possible that these organisms don't die when most of the organisms that we know die? And it turned out that what these bacteria have are thermally temperature-stable enzymes. And so, that's really interesting. What does that lead to? Well, what it has led to is the revolution in molecular biology, because one of the things that we want to do in molecular biology for cloning genes, for sequencing, ultimately for a lot of different things, is to have a piece of DNA that's amplified again and again. And what has been extracted from these bacteria are a whole number of thermally stable, temperature stable enzymes that can be used in DNA amplification. Basically what you do is you take a strand of DNA from somebody like me or a plant or something, and you heat it up, and it comes apart because it's a double strand. And then you can use these and that's done by heat, so it's hot. Then you can take these enzymes and use a DNA enzyme to replicate the DNA again and again and again, so you have a big chunk of DNA to work with. So it's very, very exciting. Completely revolutionized molecular biology, allows us to clone in bacteria insulin to make insulin affordable. So this is, again, one of these things where you have this tremendous application from some guys that are just really interested in these bacteria. How can you live in an environment like that? And it's a very fruitful area for the future as well, because there's bacteria that live in deep ocean areas. There's bacteria that don't use sunlight for energy but use a chemosynthesis. There's bacteria that survive under great pressures. All of these various kinds of organisms potentially have things in them that could be very, very useful. But the way you get at that is by having this massive basic science discovery. So if we think about some of the challenges that improve human life, we can just see where we're going with some of this. So the graph on the top left, that is just simply corn yield in Missouri, just simply to show you in Missouri how the amount of corn per hectare in our state has increased, just simply because of this continual work on corn varieties. And then if you look at the next figure, the one on the right, this is the crude death rate for infectious diseases. And you can see there's times when you have very high death rates. That was in the 1916 influenza pandemic, which caused huge mortality. And then you can begin to see the first use of penicillin is about 1945, and then the Salk vaccine for polio, and you can just see how vaccines have really changed the mortality rate. And of course, this is a confounded graph because it's not just obviously vaccines. We've had much improved public health. The thing that really, if we went way back in time, the thing where you really see, if you look at the death rate in Europe that really drops it, is due to a Hungarian called Igor Semmelweis. And what he did was he just simply told doctors that when you come from the morgue and you go to deliver a baby, just wash your hands. And so that had a really large effect. So these are the kinds of things that I think we want to do, and this is why we need to have this basic research operation. And the role of universities is absolutely critical for this. If we went back 50 years, there would be such things as Bell Labs. Bell Labs was spectacular in making new basic scientific discoveries. Bell Labs is no more. A lot of the national labs are constricting. And there is a real sense in people who think about this that universities are even more important now because we still are the place where this basic discovery is. And if we think about the future, we need to think about having basic discovery. And of course, what we do is we get basic knowledge and we foster the interdisciplinary work that helps us apply these things. And of course, we train students. And central to all of this, of course, is arts and sciences. So with that, I'm going to stop, and I'm happy to answer any questions. And thank you for not falling asleep.
How do you see you talk about breaking down silos within the university, but what about from University A to University B and C? And in our case, we have a number of universities.
Yeah.
Is that part of the vision that you would work more inclusively?
So let me repeat the question. The question was, we're trying to break down silos within the university. What about between universities? That's a really good question. It's a really good question. We see collaborations across universities, but very often it's not within a community. It will be, for example, between Washington University, I had a collaboration between Washington University, the University of Georgia, Purdue, and Stanford. You're seeing that actually quite frequently because research requires, because it's so complex, requires many different expertises. So with our rice work, we had someone who did bioinformatics at Stanford. We had someone who dealt with understanding the genomics of rice at one university. I was an evolutionary biologist. And so you have to get these teams together. I think where you see it within a community is more on some educational things. So a good example is the Missouri Botanical Garden, which is a partner of Washington University. It also partners with UMSL and St. Louis University. And so all those have worked together. But that's much harder because the missions of the universities are quite a little bit different. But I think they're partnering in education and potentially in community outreach is much more of a possibility. Hi, Sally.
Hi. You spoke in the beginning about how you expect all faculty to be involved in gaining knowledge, and that you expect them to engage their students in that endeavor as well. As you know, I think we've done a good job of that looking at the upper level laboratory courses in biology. We've been able to morph those courses into something that's not a repetitive activity, but indeed engages the students in a research activity. And that's pretty easy to visualize. So now, can we take the next step? And do you see that? So this is really two questions. Do you see that mode of teaching spreading through the humanities? The social sciences are easier for you to visualize, but through the humanities as well. And do you see ways that we can engage the freshmen, which is another challenge?
So Sally is an expert on education, so I should just ask her to answer her own question. In terms of the humanities, I think the humanities are doing a really good job of engaging students in fundamental scholarship. We see it with their thesis work. In the digital humanities, the undergrads are spectacular. So I don't think there's a difference between the disciplines. I think there is, it could be that one discipline might be doing things more than another, but I think the humanities are very vibrant on that. In terms of getting more into real research being done at the freshman level, that's a challenge. Sally, I'm sure, could talk about this for an hour. But the challenge there is when you have 500 students taking introductory biology, how do you manage that? And I'm not sure how we manage that.
Well, do we, as a university, think that is a goal?
Do we think that that's a goal? Yeah, I do. I do. It's an expensive goal. It's a logistic goal. It uses a lot of personnel, but some places do that. So I think we need to work on that. There's a lot of curricular issues we need to work on. Yes.
Yeah. I'm happy. I guess most people here that you're stressing the transference of skills and the emphasis on humanities, but if you put your scientist hat on, how do you prove the value of that experience at a university with the same degree of accuracy as you would one of your scientific experiments to other scientists?
I knew I was going to get tough questions. So that is totally profound. How do we make the case that the skills that we impart to our students give tremendous value to not only the students but to society? Anybody got any ideas? I mean, one of the things you can document is just simply looking at students that have had a lot of writing and see how they fare. But what that really involves is data at a longitudinal level, and that's pretty hard to do. I think we're trying to do that through alumni development, is to get an idea of. I'd like to know, in the last 50 years, what do biology majors do? How many go into medicine? How many of them go into business? How many of them go into the academy? You could do retrospective. We interview our students. We could ask the students what they found. But the kind of large data sets, that's something you have to think about ahead of time to figure out how to generate. Yeah. Yeah.
I'm just wondering if I appreciate the question that came before about is there a university, or is there a goal of the university for biology students and such? I'm just wondering, is there a systematic approach university-wide about asking the questions about transforming the university? Actually, to begin with, does the university need to transform, first of all? I'm just wondering if there is a systematic approach to asking the questions, asking what are the assumptions that underlie the questions, and then trying to coordinate effort among all the schools and creating a unified mission.
I think there are efforts at that. We're not very far along. Among the deans and the provosts, there's been a lot of discussion about where we see ourselves moving. It gets basically to some of the issues. The Washington University has a very interesting history. This was a commuter school basically for the St. Louis region. In the 70s, it was decided that we really wanted to reach and become a national research university. That transformation happened in the 80s and 90s. We now, in our undergraduates, the joke among the faculty is that none of us could get into WashU anymore because the kids are so great. And there's a lot of truth to that. It's not just but we've done a really good job on that. And I think we've taken that as far as we can. So now we're starting to gather data on what makes a great university, what do we need to do to keep our movement upward, because we want to be, my goal for Washington University is to be to the point where Stanford is really worrying about what new innovative thing we're doing, to make the other people that are the other universities in the top 5 really begin to get worried about us because we're just doing so well. So we really want to reach. So you start looking at what makes it, what are the aspects of great universities, and the discussion has been really swirling around faculty, graduate education, and scholarship. That we are doing a really good job with undergraduate education. That doesn't mean, I'll have something to say to that about that. We are doing well with undergraduate education. We must do the kinds of things that Sally Elgin was talking about. We need to have, we need to ever incorporate new innovative techniques in teaching that are based on how we learn, based on psychology. But we also, in that we need to keep at the forefront of that. But we also need to think about where else we have opportunities. Our faculty size, I can tell you this, we just finished a review of psychology, psychological and brain sciences, and everyone was amazed at how small our faculty is, given the number of students. We have to, I think the next step where many of us agree, we need to invest in faculty, we need to invest in really good graduate education and scholarship so that the university can move to another level. We need to be able to recruit the most innovative and brilliant minds as faculty members who will come up with the new programs and the new ideas. So there is some of that. It's at the very beginning and it's not baked in.
I would strongly encourage you to reach out to the community, because everything you just said, with all due respect, to me is very inward looking. And a lot of what you said suggests that you already have decided what questions to pursue. And I think in order to understand where WashU can improve overall, and really ask what rankings are most important, because not all of them are. There's such a rich body. I encounter this in the business school all the time. There's such a rich body of alumni. Mm-hmm. And in the business school, and I suspect it's that way throughout the university, the business school alumni always feel like, how come the only time I ever hear from WashU is when they want money? So you just asked a question of the groups in this hall, in this room right now. You just said, anybody have any ideas? And I suspect that that's the first time that most of us ever heard anybody ask that question. Mm-hmm. So the alumni, the adjuncts, I mean, there's an incredible body of information. And I think it's incumbent on the university to figure out how to ask the right questions, but how to ask for help from the outside about what questions should we even be asking.
I really resonate with this. But I had, and I think that is doable. It's a great idea. We have national councils, but those are restricted to 40 people. I thought where you were going to go with this was to ask the community, but not the WashU community, but our local community and the national community.
Everybody asks the local community, so therefore the local community I mean, the answers get diluted. And if you want to improve, if you want to say, how can WashU be, and I don't even use the word improve, but how can WashU answer the needs that are just beyond the courage of their life? Those needs that we can't quite see. If you want to focus on WashU, which is where I think your focus should be, because otherwise your question is too broad and you're never going to get there. I think you do focus on the alumni. And I think you have to go, like you just said, you have to go beyond the 40-person committee or something like that. And it's painful. It's going to be really painful for WashU to figure out how do we reach out to several thousand voices around the country, if not around the world. It's not cheap and it's not easy. It gets real ugly logistically. If you think you're juggling 16 balls now, try to figure out how you're going to do that.
This is really interesting. I'm wondering if we can continue the conversation because I think that's a really good idea.
Who is involved in your Divided City initiative outside campus, the urban initiative?
We're working, well, with the Divided City, I'm not sure, I think that they are working on the Baden project. So there's a current project, which is a local community project. So Baden is in North St. Louis, very close to the Mississippi River. It's an area where there's a lot of drainage. When there's a lot of rain, the houses flood, and so there's been a lot of abandonment of houses. The Missouri Department of Sewers, MSD, yeah. The Missouri Sewer Department has put a lot of resources into trying to figure out how to deal with the water issues. The community itself is working on trying to deal with some of the issues in terms of residents and things like that. WashU is working in terms of the environment and local community projects, and so that's one area of outreach. And in particular, there's a lot of work on outreach from the Sam Fox School to the communities.
Maybe one or two more questions.
Earlier we watched, you were studying the brain's structure and wiring of the brain. I guess that's neurotransmitter. And then you also, I know you have this big genome lab here. So if a doctor or somebody in the medical field wanted to have somebody indicate they have tendency to go for anxiety or depression, is there any way you can tie it together with the genome lab? And how do the two entities get together?
That's a great question. Did everybody hear that? You know, how do you get a physician connected to the genome lab and to the brain imaging? The teams have physicians on them. What a lot of the faculty at the medical school have a clinical aspect to what they do, and then also a research aspect. But I think that's the whole goal, is to make that connection. You know, you can some of the studies now we can see when people are under stress. You can begin to see what part of the brain lights up. There's just all kinds of fascinating things. And I don't know enough to answer your question correctly, you know, about whether now that's being used to diagnose things.
I think maybe perhaps if the genome would have an indication, it's very complicated, but it would, if certain people have tendencies for anxiety, depression, or other problems, they have certain genome structure.
Yes, I think that there's been some work on not so much the the connectome, but on genetic loci associated with some of those degrees, but some of those conditions, but it's not causal and it's very messy data. Yeah.
As you said, our technology is expanding at a tremendous rate right now. Our technology is actually doubling every 18 months. So that a freshman student here, probably his job hasn't even been invented.
Exactly. That's right. That's
So we have no idea
yeah.
what some of our students here are going to be doing in the future.
That's exactly right. Yeah. That's a Google example.
Yeah. Just to give you an example, when I went to grade school, I was still using an inkwell, ballpoint pen.
I use an inkwell as well.
But our biggest challenge is in teaching our students here communication skills, writing skills. I have a friend that says he gets people sending in resumes and they don't know how to write. Another big problem is being able to stand up in front of a group of people and speak. And I think a lot of people do not know how to do that. And yet our biggest problem is how to teach empathy and understanding for all people when they get out into the workplace, and to bring all of these communication skills, empathy and understanding, so that they know how to work with a wide, diverse people. We can turn out the smartest people in the world, they're going to go into a little bitty area and do their research or do their job. Yet they have to be able to get along and understand other people and to communicate. And I think this is one of the hardest things, and I don't even know if it's teachable. But how do we do that?
Good question. I think that's basically the point. But I think it's humanities. In terms of empathy and understanding, there has to be a solid core of humanities. And then... Just where the humanists are sitting.
I have a partial answer to your question. The best way is by example on having a proper role model on your faculty. That's the easiest way to do it.
I hope we have those role models. I know we do in many cases. Yeah.
Well, and with role models, does that mean we learn from history or we're going to repeat the mistakes of past history?
Repeat the question.
Does that mean we learn from history? Are we doomed to make the same mistakes from past history?
Looking at the debates, we're doomed.
This is going to get political in just a second.
I was just thinking the interaction and the past interaction with humanity, and now have the machines taken over, but we still need to learn from past history, things that were successful.
I think absolutely so. Otherwise, we wouldn't. I think that, to me, that's one of the most important aspects of the history department, is the analysis of why history turned out the way and what mistakes were made, what led to that. I think history gives us those lessons. Whether we choose to learn them is another issue. So
one of the biggest problems is knowing when we sort of have to end the formal part. Yet another big problem, and invite you all to continue. A couple of closing comments. Next week will be our final lecture. Holden Thorpe, the provost of the university, will be talking about a topic that has already been a buzz. It's got to do with whether or not we are a business. And so be here to take that on. He'll have some very engaging comments. Also, I invite you, if you wish to view any of these lectures, if you go to the ucollege.bristol.edu, which is the website of University College, you'll see a red link in the bottom, a YouTube link that will be able to bring this into your home. And then finally, just a quick observation about the question about asking the right questions and reaching out. I have to put this plug in. This is what continuing ed, for one thing, is for. And Barbara said there are only so many things that she can talk about, but the university is engaged in trying to figure out what are those right questions going forward, and keep your eyes and ears open. I think you'll be pleased in the directions. So again, please join me in thanking Barbara for her time.